everyone, welcome to our KDD workshop, Prescriptive Analytics for the Physical World. And this is Jessie Lee speaking from Penn State University. And here is our organizing team. Everybody made great efforts to this workshop. I would like to start with motivations to host this workshop. There are basically two motivations, as you can see from the name of the workshop. On one side is the prescriptive analytics. So the prescriptive analytics means basically how can we make prescription to solve the real world problems. And when I saw this chart, it shows 4 different types of data analytics, from descriptive analytics to diagnostic to predictive, and lastly to prescriptive. I feel this is one type of analytics that we didn't really spend a lot of efforts to study the prescriptive analytic problems. That's why I want to host this workshop to talk more about not only doing the description or prediction, but to think about more how can we actually take actions or make policies from the data to solve real world problems. So the second motivation I would like to emphasize is the physical world. So the physical world basically are the real world problems that in the physical space. I want to kind of differentiate a little bit from the online problems. For example, the problems could be the pandemic, which is still ongoing today. For example, how can we design intervention policies to contain pandemic? And also, for example, how can we save energy? Or how can we do better resource allocation, like taxi dispatching? So these are all real world problems that are very important to human world. And that's basically why we host this workshop called Prescriptive Analytics for the Physical World. So in this workshop, we invited 6 great speakers. So in the following, I would like to just give a very brief highlight for each of the speakers and to give you kind of a very quick overview why we invited them and what their talk will cover. So the first is from Alex Bayan from UC Berkeley, and this talk was actually given by his student Jessica. So Alex and his group, their expertise is optimization control, and in particular with the applications in transportation. They did a lot of framework or systems such as Bistro they talk about in this talk, and also we've used the flow. So there are many different systems developed by their group to solve the transportation problems. And in this particular talk, Jessica will talk about multi-objective transportation system optimization. In particular, if you're interested in the question, how to find the best congestion pricing strategy, you should go and listen to her talk. Next one is Dr. Stephen Eubank from University of Virginia. I actually got to know Dr. Eubank from his famous work in epidemics. So he is actually quite famous for his work in simulations for epidemics and transportation. If maybe you heard of this MPSIMs or TransSIMs are the simulations for epidemics and transportation. And in particular, he also has expertise in the policy informatics, which I'm very interested in, is how to make policies based on the knowledge you learned from the simulation. If you're interested in that question, go and listen to his talk. Next one is Marta Gonzalez. Dr. Gonzalez is from UC Berkeley, and her expertise, many of us probably already know, is in network science, and particularly she did a lot of work in analyzing the large-scale human mobility data and discover the science in those data. And in this particular talk, she will focus on urban modeling and planning. In particular, he will address this question: how to use novel data sources such as mobile phone data or POI data to better model our city so we can have better urban planning systems. So next will be Jim Gao. Actually, I didn't know Jim before, but I read one of his technical report, which I found very interesting. It's about how to use machine learning to save energy for Google data center. That was actually a technical report. I think it was released in 2014. But very impressively, they actually reported the method helped Google saved 40% energy in cooling Google's data centers. So Jim recently left Google and DeepMind. He started his own company called Phaedra, which is also working on the similar problems, is energy efficient buildings. And if you are interested in the real industry experience about how to use machine learning to save energy, you should definitely watch Jim's talk. Unfortunately, Jim's talk is not available on YouTube, so please go to the KDD conference virtual platform and you can find his talk there. And next will be Dr. Jieping Ye from DD, and also he's a professor from University of Michigan. So Dr. Ye's expertise is in machine learning, and of course, because now he works for DD and he has a lot of real world industry experience in ride sharing. If you talk about anything AI in DD, you should go for Dr. Ye. And he shared the real experience, his experience about how to use reinforcement learning for taxi dispatching. And that's also an online system that's currently running at DD. If you're interested in that, that topic, you should definitely watch his talk. Last but not least is Dr. Yang Yu from Nanjing University. I got to know Dr. Yu's work from his several work on reinforcement learning, particularly his recent work on Taobao. So they actually use the reinforcement learning for e-commerce search. And they recently had a virtual Taobao, which is currently being used by Taobao to support the reinforcement learning algorithms at Taobao. So if you are interested in the question, how to use reinforcement learning for e-commerce search, you should definitely watch his talk. So those are the 6 invited talks, and our workshop also features a challenge on epidemic intervention. So of course, the motivation of this challenge is the pandemic, COVID-19 pandemic that's going on right now. And we are thinking about, is how can we design the intervention strategies so to better contain the pandemic. And so the idea of this challenge is like this. So the participants can choose the intervention action for each individual, and the actions can be put this person into a hospital, or isolate, or quarantine, or confine in a neighborhood. So there are 4 different types of strategies you can use. And once you take the action, it will run a microscopic simulator, as you can see on this visualization. And it will return the state back to the agent. And then lastly, the score will be a combination of the number of interventions and the number of people who are infected. We want to minimize both. As you can see on this visualization here, it shows as time goes by, the number of infected people increase and also the number of interventions increase, but eventually, hopefully, to bend the curve. So that's the idea of the challenge. And we started challenge in May, and the official, at that time, we provide some, like toy online intervention platform for people to play with. And then the official competition starts in late June, and it concluded 3 weeks later, and the winners were announced a month before. In particular, we like to thank all the organizers and also the companies for their support of this challenge. So we received more than 5,000 submissions for this online case. Like, people can choose different kind of intervention strategies for different kind of cases, like the critical case, the symptomatic cases, and then they can see how the simulations is running, and they can see the curve of number of intervention and number of infected people. So we received more than 5,000 submissions to play with that, which is quite impressive. And for the official competition, we had 65 registered participants and more than 200 submissions. And among those 200 submissions, finally, we got our top 5 teams for this challenge. And we had their talk and also their papers talking about detailed solution, which are all posted publicly on our website. You can go and check it out. Actually, very interestingly, all the participants use quite different kind of methods, including reinforcement learning, genetic algorithm, precision recall balancing, or expert in loop. So go ahead and check out their papers. They show very different and interesting solutions. So that's it. And thank you very much to participate in our workshop, and I hope you enjoy it. Have a good day. Bye.